Today we're going to look at solving a 3x3 system. 3x3 systems, a lot more work than the regular 2x2 systems. Here's how they'll look easy to us. If we saw a 3x3 system like this one, you don't need to write this one down. To kind of give us an idea. This 3x3 system would seem a lot easier to us because we already know one of them. Then we could back substitute in the one before, and that'll give us the second one. So if I did 3 times 10 plus 2y is 2. So 2y is what? Negative 28. So y is negative 14. Now I have x and y. I can go back in the top one to get the third variable. That's a much easier 3x3 system. Easier because we've got this situation right here. For one variable we know. We're back substituting one variable into a one equation, two unknown, like we saw before, and just kind of working our way back. Our goal is to take something like this and get it down to solve for one variable. Because if we can solve it for one, it doesn't matter if it's x, y, or z. Once I get one of the variables solved for, then I can start doing that back substitution to get the others. So that's going to be our goal. What we feel pretty confident in at this point is if I was asked to solve a system like this. 2 equation, 2 unknown. Feel pretty confident on solving those. Okay? So what we want to do is reduce this guy down to one of these, and then we're back doing what we did before. All right, so the way that we do that, so that we can get 2 equations, 2 unknowns, is we want to eliminate the same variable twice. It does not matter if you get rid of x, you get rid of y, or you get rid of z. But you want to get rid of the same one twice because that's going to get us down to that reduced system. Okay? I mean, we see some things here. You know, we can get a negative 2 here, get rid of an x. Those y's go, have to do something with this one. These z's go. Typically, there's not one that's necessarily easier than the other. But we've got to get rid of one. Which one you want to get rid of, x, y, or z? I heard y first. That's what we're going for. So I see this right here. Okay. Now here's one of the things becomes very helpful, especially going forward when you get to matrices and other larger systems. Okay. Use some codes to kind of help you remember what you did. You can tell that if you add these first 2 equations, the y's go away. Does everybody agree with that? So one of the things that's nice to do like R1 plus R2. Row 1 plus row 2. I'm going to add these 2 together. That would give me 3x. The y's go minus z equals 3. And the reason I say this is a good idea to write down is because you look back at your work 10 minutes from now, you're going to wonder where in the world that equation came from. Be more a day or 2 or 3 days from now when you're trying to look back and figure out what you did. That helps you. That'll remind you what you did. You added those first 2 rows. Okay. Now I've got to get rid of y again. Chose y, we got to do it again. We're going to have to use this guy. So I can use either row 1 with row 3, or I can do 2 with row 3, but I've got to use row 3. I haven't used it yet. Okay. I would probably say 1 and 3. So think back to what we did before. If you distribute a 2 here, when you have 2y and negative 2y, remind us what we did. So I'm going to say 2 times row 1 plus row 3. So again, this is what's nice to have, especially going forward on your papers. 2r1 plus r3. It's going to tell me what I did when I look back at it. So 2r1, 2x, plus 2y plus 2z is 8. We distributed a value through there before. R3, x minus 2y minus z is 1. That would give me 3x plus z is 9. Y's went away like I wanted. I really do think these are going to definitely benefit you, not just now looking back, but in the future. You're used to knowing what's going on there, and it's telling me what I did. Now look at what we have left. We have a 3x minus z is 3, and a 3x plus z is 9, and we're back to doing what we did before. It's not finished. It's not necessarily easy, but it definitely looks a lot better than what we started with right here. I have gotten back to some familiar territory. Sometimes we'd have to multiply here to get rid of a variable. I don't in this case because the z's will cancel out. Just the way it worked out this time. So 6z is 12. Z is 2. I've got one of them. Now I can back substitute. I'll go on the bottom one. 3x plus 2 is 9. Did I mess up? Oh, yeah. 6x. Helps if I write the right variable, right? So x equals 2. So 3 times 2 plus z is 9. Thank you. Z3. It's always the careless mistakes that get us. Every now and then. All right, we okay with z is 3? And now we need the y. It doesn't matter. Okay? I personally probably would pick the top one. No particular reason other than I just see pluses. But x plus y plus z is 4. All right, so let's see. 2 plus y plus 3 is 4. Y is negative 2. Now, our solution. When we write our solution, what we want to make sure of is we write it as that ordered triple. So the answer would be, I made another one. That's a negative 1. It's one of those mornings. So our answer would be 2, negative 1, 3. Right, so we want to write it as an ordered triple. 2, negative 1, 3. So we're just going to go x, y, z. Most of the time, your variables are x, y, z, because in a three-dimensional coordinate system, it's an x plane, a y plane, and a z plane. There's 3 different axes there. Right? This would be that three-dimensional point where they're crossing. Instead of a two-dimensional like we saw before with 2 equations, 2 unknowns. So if you can kind of visualize 3 random lines going across the room somehow, there's that point where these 3 are connecting. So if you imagine that, it is possible that none of the 3 would connect. That would be a no solution. If you happen to see different variables, A, B, C, whatever variable is first is going first. Typically it's X, Y, Z, but variables get changed. It doesn't matter. Your ordered triple is just whatever the first, second, third variable was, what we're looking for. How about this? Let's go with 4x minus y plus 3z is 10. X plus y minus z is 5. 8x minus 2y plus 6z is 10. Now remember, first thing we have to consider is what variable we want to get rid of, and we have to get rid of that same variable twice. So whichever one I pick, I've got to do it twice. Okay? I can't get rid of x one time, then y one time. I've got to pick the same one. Which one would you like me to get rid of, x, y, or z? Y. Y, okay. So I can see right away if I get rid of y, I'm just going to write what I'm doing, eliminate y. I can see if I add R1 plus R2, the y's are going to go away. Gives me what I want. So 5x plus 2z is 15. Now I've got to get rid of y again. So I've got to use row 3. Do you want to use 1 and 3 or 2 and 3? 2 times 2 plus, so 2r2 plus r3. So that's going to give me a 2y right here, the negative 2y. So 2x plus 2y minus 2z is 10. I'll rewrite my row 3. I'm going to have 10x plus 4z is 20. Now I've got 2 equations, 2 unknowns. Getting back a little bit more of my comfort zone working with these 2. So I'm just going to rewrite them over here. Now this time I have to do some multiplying. What do we want to do next to get rid of one of these? What's that? Z. Do you want to get rid of z? Okay. So what do you want to multiply the top by to get rid of z? Negative 2, all right. Negative 10x minus 4z, negative 30. 10x plus 4z, 20. What happens here? Both go away, right? X's and the z's. Usually my first thought then is I made a mistake. I look back, looks good, distribute, looks, yeah, they go away. So now here's the question for you. Is it no solution or infinite solutions? No solution, because we had a false statement. So what we talked about before, previously, if you eliminated all variables, which happens, you're either going to be left with a true statement or a false statement. And that's false. 0 does not equal negative 10. Okay? That's what's going to tell me no solution, which just simply means there is no point where these 3 lines cross. There is no point. I can't tell that from the start. My process, I'm picking what I want to get rid of, doing it twice, work with what I've got. I'm not going to be able to see that from the very start. Sticking to my process. What if I gave you something like this? Let's go x minus 2y plus 2z is 9. Negative x plus 3y equals negative 4. And 2x minus 5y plus c is 10. Now remember, I got to pick whatever I want to eliminate and eliminate that variable twice. This would be a situation where for me, I would probably pick to eliminate z because then I only have to eliminate it once. I already have one equation without a z. If I pick x, I'm going to have to do it twice. If I pick y, I'm going to have to do it twice. If I pick z, I can do it once because I still got this guy. A lot of times it's what you see. I'm going to do z this time just to do z, but a lot of you, including myself sometimes, but first look at this, I see this right away. This x is going away. Right? So I can't really say one way is faster than the other. I'm going to eliminate z here. Just because one's gone, so I've got to use these 2. So I'm going to do R1 plus negative 2 R3. Remember, this code is what's helping us. Not just for looking back, reviewing, but for what we're going to do in the future. We're just kind of writing down what we're thinking. -2, because I'm looking right here. -2z and 2z, that'll give me 0. That's what I'm looking for. So I'm going to rewrite my first one. X minus 2y plus 2z is 9. All right, I'll distribute my -2 on my third one. -4x plus 10y minus 2z, -20. Z's go, that's what I wanted. -3x plus 8y, -11. Rewrite my new system up here. That was my row 2 that didn't have a z. And here's the one I just created. All right, what do you want to get rid of here, x or y? X. If I get rid of x, let's say multiply the top by -3. Does that sound good? So let's see here. 3x minus 9y, 12. Rewrite my other one. -y is 1, so that means y is -1, and then I'm on my way. Once I get that first one, things speed up for me. So I'm going to back substitute now. Let's see, I'll do the top one. Now remember, when we're picking which one we want to back substitute into, it's just personal choice. So I'd have -x minus 3 is -4. -x is -1, so x is 1. There's my second one. Then I go for my third one. I've got x and y, so I'm going to have to use the top or the bottom. I'll go to the bottom one this time. Rewrite it over here. 2x minus 5y plus z is 10. So 2 times 1. 5 times -5 times -1. Let's see, 2 plus 5 plus z is 10. Z is 3. So we have 1, -1, 3 for my answer. Looking okay to everyone? We've got to make sure we eliminate the same variable twice. Sometimes we get lucky and one's already gone. Okay, so we can go for that one. If that's not the case, or and you don't need to rewrite this or anything, if I looked at something like this and saw, hey, if I want to get rid of x, I can do that. Eliminate x. Y plus 2z is 5 if I add 1 and 2. And then I could go 2r2 plus r3. So that would be -2x plus 6y is -8. 2x minus 5y plus z is 10. This gives me y plus z is 2. And I'm still back to 2 equations, 2 unknowns. Okay? I can't really say one way is easier than the other. Okay? I was drawn to z because I see it gone. To get rid of x, these two aren't too bad to work with. I'd have y plus 2z is 5. And y plus z is 2. I want to get rid of y, -1. Y plus 2z is 5. and negative y minus z, negative 2, z is 3. You'll start back substituting. We'll come up with that same point. Right? So sometimes I can get rid of it one time because I see something missing. Otherwise, I've always got to do it twice, same variable twice, so that I get this system. We want a 2 equation, 2 unknown, because that's what's most familiar to us. Sound okay to everyone? Yes. All right.